Dear students, in this lecture we are going to give a short introduction to dynamic programming. What dynamic programming is? Dynamic programming is a strategy to find optimal solution of multivariable problem. In dynamic programming, a problem is decomposed into several stages. Each stage is a single variable subproblem. The main advantage of dynamic programming is each subproblem involves one variable only. The property of dynamic programming is overlapping subproblems. What is overlapping subproblems? The output of a subproblem is given as input to another subproblem. In other words, subproblems are dependent of each other. That is, optimal solution of one subproblem is used as input to next subproblem. In computational process of dynamic programming, computed solutions are stored and used when needed. Hence, the computations in dynamic programming are done recursively. If the subproblems are independent, then we cannot use dynamic programming. Rather, we have to use another strategy called as divide and conquer strategy. Dynamic programming is based on principle of optimality, which is defined by Bellman. In simple terms, in an optimal sequences of decisions or choices, each subsequence must also be optimal. So in order to understand the meaning of principle of optimality, let us consider an example. Let us take a shortest path problem of reaching from Coimbatore to Chennai via various other cities like Salem, Trichy, Viluppuram, Kanchipuram. Now, in order to find the shortest route from Coimbatore to Chennai, we divide this problem into subproblems. So, initially, we consider optimal way of reaching Salem and Trichy in stage 1. So, the subproblem of Coimbatore to Salem optimally is considered by taking the distance and the number of paths. Here, we have only one path from Coimbatore to Salem. The distance is 5. So the optimal way of reaching from Coimbatore to Salem is 5. And considering Coimbatore to Trichy, only one path is available. The distance is 4. So in stage 1, we have written the distance as 4 here and 5 here. So in the next stage, we consider the problem of reaching Viluppuram and Kanchipuram. Let us take Viluppuram. What is the optimal way of reaching Viluppuram? Viluppuram can be reached from two cities, Salem and Trichy. So from Salem, we have to already consider the problem of reaching optimally to Salem, which has been stored in the earlier computation. So which is 5. And similarly, the optimal way of reaching Trichy is stored, which is 4. So now, Salem to Viluppuram, the total distance is 5 plus 6 equal to 11, or Trichy to Viluppuram, the total distance is 4 plus 8, which is 12. So out of this 11 and 12, the shortest distance is 11. So the optimal way of reaching from Salem to Viluppuram is 11, which is stored here. Similarly, consider Kanchipuram. The optimal path for reaching from Salem to Kanchipuram should be considered. Already we have stored the distance as 5 and the distance from Salem to Kanchipuram is 7. So total distance is now 12. We have to consider another path, Trichy to Kanchipuram. In Trichy already we have computed the distance 4 plus the distance from Trichy to Kanchipuram is 9. So totally it is 13. So out of this 13 and 12, minimum distance is 12. So which is written here. Now we have to consider reaching Chennai either from Viluppuram or Kanchipuram by using the pre-computed results. The pre-computed optimal result is 11 here. So 11 plus 7 will give you 18. The pre-computed result for Kanchipuram is 12. 12 plus 10 will give you 22. So out of this 22 and 18, minimum is 18. So this is the optimal path. So the Viluppuram to Chennai, which is the optimal path. So this path is optimal. Again from Viluppuram, We can optimally reach Viluppuram from Salem. So Salem to Viluppuram is an optimal. Again we can reach Salem optimally from Coimbatore. So Coimbatore to Salem is optimum. So the subsequences are Coimbatore to Salem, Salem to Viluppuram, Viluppuram to Chennai. All these subsequences are optimal. So the entire path Coimbatore to Chennai is optimum, as well as the subsequence problem Viluppuram to Chennai, Salem to Viluppuram, Coimbatore to Salem are also optimal. This is the principle of optimality. In our next lecture, we will solve the shortest route problem using dynamic programming computations. Thank you.